Hey guys, Mr. Milton here. Today we're going to talk about finding the area of regular polygons, number 2. So, today we're going to find the area of regular polygons using trig. You see the last lesson was using special right triangles. And the formula that we derived for finding the area of a regular polygon was the area of a regular polygon was 1/2 the apothem times the perimeter. Okay. The shapes that we used were triangles, squares, and hexagons. Okay, and we used these figures because these shapes made special right triangles. The 30, 60, 90 triangles and the 45, 45, 90 triangles. Okay, but what happens when the figure does not make a special right triangle? Okay, so let's look. This is a regular pentagon. Okay, pentagon, 5 sides. The process pretty much stays the same as far as we're still looking for the central angle, and that is XCZ here. It's a central angle. We can find that, remember, by doing 360 divided by the number of sides, and that will give us 72 degrees. And then angle YCZ here, that will be half of that central angle, which is 36 degrees. Okay, we know the perimeter. That's a big part of our equation, and that's going to be 8 times 5, or 40 centimeters. And how do we find the other pieces that we need in order to find this? We have to use trig. Okay, because remember, for our area, and that's what we're going to find here, area equals 1/2 the apothem times the perimeter. Like we said, we know the apothem's 40. I'm sorry, the perimeter's 40. Now we have to find the apothem. Okay, and so with this information, I have this is 36. This is a 90-degree angle. This side was 8, so when we split it with the apothem, that's going to be 4. We have to find this, x. And we have to use trig. So, what's the exact value for this missing piece? Well, we can find that exact value by solving the triangle with trig. Okay, and so what we know then, we know this is 90, we know this is 36, I want to find x, I know this is 4. So in order to find x, I'm going to use my trig, my SOHCAHTOA. I have the opposite side and my adjacent side. So I can say tangent, I'll write it here, tangent 36 equals opposite 4 over adjacent x. And now I have to solve for x. Okay, and so I get x tangent 36 equals 4. I'll divide by tangent 36 on both sides. And now that gives me my exact value, x equals 4 over tangent 36. Okay, now that's my exact value. And I know it's my exact value. I don't have to round anything. That's it. So now I can use that, and I'll try to use, and I will use my exact value in my formula, so therefore I don't mess up and round early and affect what my final answer is. So I can find the area of this pentagon by doing 1/2 the apothem, which will be 4 over tangent 36, and you can use that, remember, in your calculator. I'll show you in your calculator how to do that, times the perimeter, which we said was 40. Okay, so now go into my calculator. I'm going to do 4 over tangent 36. Okay, that gives me a big long number. I'm going to multiply that by 40. Okay, and then I'm going to divide that by 2. You see, I did not have to round anything. And so then my final answer is 110.1. What was that figure? Centimeters squared. Okay. the bigger your numbers are, the more rounding incorrectly or rounding at all really will affect your answer. So when possible, we want to use our exact value to get to our final answer. All right, it says find the area of a regular octagon with a radius of 9 feet. Give your answer to the nearest tenth. So I can draw this octagon out. Maybe, hopefully I remember how to draw an octagon. Nope, that's definitely going to be a hexagon. Nope, I got it. Alright, so it won't be pretty, but that's okay. I'm going to find my triangle. I'm going to use it to find my sides, and then we'll be on our way. Alright, so they told us that in this octagon I'm going to draw a center, I'm going to draw my apothem, I'm going to draw my radius, which they told us was 9. I know that my apothem will be perpendicular, so it'll make a 90-degree angle here. I need to find this angle, okay? We can find that angle, remember, because we have 360 divided by 8. That will give us the central angle, okay? This will be 360 divided by 8. And that should just be 45. Alright? And so that whole angle is 45. The apothem breaks it down and makes it half of that, which will be 22.5. So, now, I need to find this side and this side. I need to find my apothem, and I also need to find the side so that I can find my perimeter. So I'm going to draw this triangle out just because I'm working with that for the most part. This is 22.5. This is 9. X, Y. Just back to our SOHCAHTOA stuff. If I'm using opposite over hypotenuse, so I'll say sine of 22.5 equals opposite x over 9. So x will equal 9 times sine 22.5. Alright, and so I'm going to find out what that is. 9 times sine 22.5. Oops, messed up and put 0.6. Okay, and that will give me 3.4 repeating. Alright, that side then will be double that. So we see that a side length is going to be 6.8. So x is like 3.44. Okay, and again, I don't really want to have to round things. So I'm writing this down so you see where these numbers come from, but I don't want to round things. And so I'm just going to go ahead and I found the side to be 6.8. I'm going to go ahead and just find out what this perimeter will be. I'm going to multiply that by 8. Okay, so I'm going to do my perimeter then is going to be 55.1, and I'll just write 06 at this point. Okay, so I'm going to use that in my final formula. The other piece that I need for my final formula is the apothem. Okay, and that's the adjacent side, and I have the hypotenuse, so I'm going to use cosine. Cosine 22.5 equals the adjacent y over the hypotenuse 9. I can find y by 9 times cosine 22.5. 9 cosine 22.5, and that gives me 8.31111. Okay, so I'll write that down again for our benefit, but in my calculator I'm going to just use that whole value. So my formula then will be area will equal 1/2 the apothem, I'll just write 9 cosine 22.5 here, times the perimeter, which is 55.106. Okay, sorry I ran out of space, but I'm going to use that whole thing in here. So in my calculator I have the apothem times the perimeter divided by 2, or times 1/2. So my area will be 22.9 feet. Or sorry, 229.1 feet to the nearest tenth squared, because it's area. Okay, so now we're just using trig to be able to find those sides and missing measurement. Okay, This next formula is going to seem a little bit unconnected with what we're doing, but we're doing it now because it involves area and trig. Okay. In the triangle below, we only know B, C, and the measure of angle A. So all the things in blue. I'm going to show you kind of how H and these sides are related. Alright, so we all know the area of the triangle is 1/2 base times height. 1/2 base times height. Okay. Now, we don't know the height in this case, and so this is why it's going to be important to see how it's related to A, B, and C. If we want to find this height, well, let's just look at this. This height, actually sine A is going to be the opposite over the hypotenuse. This height over C, that side. And so if we want to get height by itself, we could multiply both sides by C, and we would see that C sine A will equal the height. And so what we see here, H equals C sine A. And so what we can do is actually put this in our equation, and we can find the area by doing 1/2 B C sine A. I shouldn't put that in. B C sine A. And that's how we find the area in a new way. Alright, so let's put that into practice here. If I want to find the area of this triangle, see, I would have to find the height. Okay, we could do that and do all the right trig stuff, but the shortcut or the different way to do that is we could say, okay, area equals 1/2 our base which would be 26, times our other side, which is 12, sine 76. Okay, and I can put all that into the calculator at one time. 1/2 26 times 12 times sine 76. And I can see the area of this triangle is going to be 151 point, we'll just say 37 to the nearest hundredth millimeters squared. Okay. Number 2, notice we're given all three sides. We will use the sides that are including an angle. So 9 and 17, where 67 is the included angle, that's the sides that we'll use. And so our formula in this case will be 1/2 9 times 17 sine 67. Again, we can put that all in our calculator. 1/2 9 times 17 sine 67. Okay, and that gives us 70.4. So the area of this figure will be 70.42 inches squared. Okay. All right. So we talked more about finding the area of regular polygons using the 1/2 approximation perimeter equation, and then we also talked about trying to find area of triangles in a different way using 1/2 BC sine A. All right. See ya.